Good morning, everybody. Very nice to meet you. My name is Charlie Chen, and I'm the CEO of Kilopass. Happy to be here in Seoul to introduce our new technology. And so I'm going to get started. So I'm going to outline what I'm going to talk about today. I'll first talk a little bit about the company, as some of you may not be familiar with us. I will go into a little bit of our core technology and core business today, which is OTP. It is what generates the revenue for us to invest in VLT development. And before I go into VLT, I will talk about the DRAM market, the growth, and also some of the challenges in the DRAM business. DRAM is obviously a very large business in Korea, and I will discuss a little bit about that. Then I will go into a somewhat technical introduction of the VLT technology and why it is revolutionary and also compelling for the DRAM business. And then after that, I will go quickly a little bit about how we intend to enter the market and enable our licensees to capture the revenues in DRAM business, and then summarize today's discussion with 4 key points. So first, now I'm going to talk about Kilopass. The company was founded in 2001 and based in headquartered in San Jose. Today we have about 65, 70 employees. Since I joined the company at the end of 2008, the company has grown 10 times in size, all based on our OTP technology. We have about 70 patents, about 250 customers, and thanks to our, in large part, to very good customers in Korea, we've shipped more than 10 billion chips worldwide. And we're also the first to go into mass production at TSMC 10 nanometer, replacing fuse. And this OTP business is what enables us to invest into the VLT. So when you come to the conference, you may ask, how can a small company develop a DRAM technology? So I would say that Kilopass is a little bit different. We have, through our OTP business, done 80 projects, and they are very different projects from the traditional DRAM or NAND flash companies, from Power IC to BiCMOS to FinFET, high voltage. Our TD team has to touch many different manufacturing processes. So we have a very broad understanding of the technology, and that helps us develop the VLT technology. Now, it could be used for SRAM and DRAM and has very compelling benefits, but today I'm just going to focus on DRAM. So now I'm going to talk about the OTP technology quickly. It's the technology that gives us the revenue that we have today. So if you want to embed data inside of a SoC or a chip, there are basically 4 technologies: ROM, fuse, embedded flash, and the Kilopass OTP. And they all have their advantages and disadvantages. For example, ROM is very, very small. Fuse is available from every fab. And embedded flash is very flexible. You can write multiple times. But you can also see that the Kilopass has the best compromises of all the different considerations. So this is why our OTP is in more than 60% of all the DRAM shipped worldwide today. And it's also the reason why our OTP is inside the newest mobile phones, 10 nanometer and 7 nanometer. And the security is probably the most important reasons why we think the OTP business will go into the next phase of growth. So our vision is to use OTP to enable the next generation of mobile wallet. So from 2004, when we developed the first HDMI key technology, to 2008, when we became the standard for IPTV and set-top box. And then in 2010, we became the technology that the US Pentagon uses for secure memory. We've learned a lot about how to make OTP memory very secure. And we believe that that's also the technology that will enable the next generation of mobile wallet function where you can store personal data inside your mobile phone. Now next, I'm going to give you the Kilopass perspective, perhaps my perspective on the DRAM business. Korea has a lot of expertise in DRAM, a lot of business in DRAM. So I think the audience here, editors and analysts, probably knows more than I do about DRAM. But I'll give you my perspective. So DRAM is about $50 billion. It depends on ASP. It depends on fab capacity, but it's about 50 billion. The two critical issues, one of them is that mobile phone is no longer the growth engine for DRAM. In the last 10 years, it's grown. The next 10 years, I believe it's going to be in the cloud. DRAM revenue depends on the cloud. Servers, data center, depends on computing, deep learning, issues that requires computing power. The problem of traditional DRAM, though, is that it requires refresh. And refresh takes the bandwidth away from the DRAM. So at 8 to 16 gigabit, you can see the available bandwidth net of refresh is decreasing very rapidly. So this capacitor that requires refresh has a different problem. The second problem with the capacitor is that it slows down the scaling. And you can see that Samsung, TSMC, Intel are all going to 7 nanometer for SoC. NAND flash is in 10 nanometer going to 7 as well, and it's 3D. But DRAM is stuck. The most advanced DRAM today will be at 1x nanometer, maybe 18 nanometer, but that is not moving down fast enough to provide the customer's requirement. So the capacitor really is a problem. So to give you an illustration of the problem, the transistor in 20 nanometer is right about here. It has the dimension of about 30 nanometer times 30 nanometer, and that's the size of the transistor. However, the capacitor is almost twice the area. What's worse is that it's 1,000 nanometer in height. It's extremely tall and makes it very difficult to manufacture. Okay. In 3D NAND, it's also tall, but every pillar stores 32, 64 bits. Here, every capacitor stores just one piece of data. With the introduction of the DRAM market and the challenges, now I'm going to go to talk about VLT. So before we go to the technology, and I just wanted to say that, this is not the first time the industry has seen a big problem. If you look at 1990, how to increase the bandwidth of mobile phone. 1995, how to move the flash memory technology into computer. And in 2000, how to do 802.11a, which is the first wireless technology. These are all very difficult technologies the industry faces. Okay. And obviously, in each one of the industry, there are some very big companies on this list that can provide the solutions. And so I don't need to introduce these companies, but the companies that actually provided the solutions, at the time, nobody has heard of. Nobody knows Qualcomm. Nobody knows SanDisk. Nobody knows Atheros. And most people don't know Kilopass. But Qualcomm brought CDMA, which at the time was for truck drivers, to mobile phone. SanDisk brought the file system to NAND flash. So NAND flash can be today's SSD. And then Atheros created what we know today as baseband. Before Atheros, there was no concept of baseband. And I think Kilopass is going to introduce VLT to the world. So this is what VLT looks like. On the top, I will explain what it looks like as a transistor. It's very similar to the traditional silicon wafer. We simply add two implants, the shallow N well and shallow P well. What it does is it forms two bipolar transistors that are locked together to form a memory latch. Because of that, it does not use any new material like magnetic RAM or resistor RAMs. It's 100% CMOS manufacturing process compatible. It's incredibly stable. The physics is very, very well known. The physics of thyristor was invented in 1950. So the physics is very well known, and we've proven it in silicon. So down below, you can see that on the left, it's what the engineers call the IV curve, voltage and current. And you can see several things. The thyristor is very, very fast. Once it turns on, it takes tens of picoseconds to turn on. It is the fastest memory available. What Kilopass discovered was that at standby, the power consumption is extremely low. That perhaps is the physics that nobody realized until we discovered it. And the third thing is that the difference between on and off is 100 million times the difference. And we like that in memory because it's easy to design sense amplifier. It's easy to design circuit because 0 and 1s are so clearly different. So I want to merge the two and show you the perspective. You could see that without the capacitor, this big, huge tower will not be necessary. But more importantly, you could see that the VLT fits neatly underneath, and it's the size of the transistor. So now DRAM manufacturer can go down to 16, 14, 10 nanometer, even to 7 nanometer with our VLT technology. It's lower cost and much, much higher in yield and much easier to manufacture. So if we compare, 1T, 1C to the traditional DRAM and VLT, you could see that with temperature, the traditional DRAM dissipates just a lot more power, and it will get worse when DRAM in data center and cloud becomes more important market. And obviously, without the refresh issues, we can maintain the 100% availability to the chip. And so next, I'm going to show you why VLT costs less, about 45% less. First, compared to DRAM, the VLT is about 4.5 F squared, and DRAM is today at 6 F squared. And then, if you look at the macro, the Kilopass macro is about 75% efficient. Today's DRAM is about 64-65% efficient. So the higher the efficiency, the smaller the area. The last, because there are fewer masking steps that's required to build the capacitor, we don't use the capacitor. The mask cost, the manufacturing processing cost is a lot lower. When you combine the three, it's easily 45% less expensive. So this next slide just shows the area difference between 8 gigabit DDR4 versus our version of DDR4, and we're about 31% smaller. So in terms of technology, this next slide talk about what is required. And in essence, this is the most important slide. So whether it's the SoC business or the traditional DRAM business or the VLT business, they all start with CMOS technology. So the top 4 semiconductor companies in the world that have the best CMOS technologies are Intel, Samsung, TSMC, and maybe one else, okay, and Hynix, okay. So the CMOS technology is very, very difficult, okay. Obviously, IBM has it, but today IBM is more using global foundries as fab. What makes VLT different is that because it does not require the capacitor technology, customers can use our VLT technology and quickly go down and leverage their CMOS technology excellence. So you may ask me, well, sounds good. How do I know it works? And this slide talked about how we gain the confidence that it works. First, VLT is very unique that it does not use anything new. It uses all the existing materials that's well done inside the fab already. So there is no change in the physics. We just use a different device. Secondly, we develop a very, very fast device simulator in Kilopass that allow us to simulate very, very fast. As a result, we have 30 very difficult tests. We test all 14 key manufacturing parameters in temperature corners, voltage corners, to guarantee that our licensees in 20 to 31 nanometers can go to manufacturing. They know their yield and manufacturing window target 15 months before they start. So next, I'm going to talk about the market strategy and how you can, how we can introduce VLT into the DRAM market. So DRAM business is rather unique in that it has a very complete spec from JEDEC. It also has a very rich ecosystem, DIMM modules, DIMM buffer, DDR controllers. It's all well established. So I think it's easy for us to imagine that we will first go into the industry standard-based market, PC and server. Okay. And as the market grows in the first, second phase, we can imagine going into the embedded market as well as the mobile market, leveraging the unique benefits of the VLT technology. So now I'm going to summarize the 4 key points that we talked about today so that you can think of VLT this way. First, because DRAM business is a commodity business, it is about cost. Cost that meets the standard. And VLT lowers the cost by 45%. Secondly, it's easy to manufacture. So it makes the technology easy to migrate to 7 nanometer, providing you have a good CMOS foundation. It makes it easy. Number 3, there is no capacitor technology that's needed anymore. And lastly, that Kilopass is going to use, we are going to use what's called the protective licensing. We are going to license the very small number of licensees so that there will not be a price war and the collapse of the ASP.